Welcome to the Calculus 2 class. We're gonna study polar coordinates in this session. We study parametric equation in previous session. Parametric equation means we have extra parameter to represent curve. But in this session, we're gonna study polar coordinate. We're gonna represent curve with radius and angle. So first, we're gonna locate, describe points in the plane, coordinate plane using polar coordinates. Second, convert point between rectangular coordinate, polar coordinate form. Third one, we sketch polar curves from given equation using key angles and symmetry. And finally, we convert the equation between rectangular coordinate and polar coordinate. Let's get started polar coordinate. Before I introduce polar coordinates r and theta, let's review Gaussian coordinates, another way say rectangular coordinates. You have x-axis, you need y-axis. They meet the middle, that's the origin. Let's plot the point on the plane. That's gonna be P, x1, y1. How can get the x1? x1 is distance from the y-axis. Another say this is x1. That's gonna be y1, distance from the x-axis. That's the y1. Then how gonna define polar coordinate? Polar coordinate origin 0 we call pole or origin. Draw the line that's the positive x-axis. We say polar axis. Then you're gonna plot the point on the plane. Then we're gonna connect the 2 points, origin and point, that's the line. First, we're gonna define the angle between the two lines. That's gonna be theta, directed angle. The positive angle gonna be counterclockwise. Negative angle gonna be clockwise. So first you define the angle counterclockwise from the polar axis to the segment OP. That's the angle. We're gonna define the R, that's gonna be distance between 0 and P. We're gonna define R. So R is a distance from 0 and P. Then we're gonna define polar coordinate, R and theta. Don't mess up the disorder. R is first, angle is second. These slides, we're gonna define polar coordinates, negative r and theta. Previous slides, we define 0 is origin. That's the polar axis. That's a positive x-axis. We're gonna plot the point r and theta. How gonna define r and theta? First, draw the line segment right here, guys. Then we say this is angle theta. Then distance from the 0 in this point, that's gonna be r. That's how to define r and theta. So here is r is positive. Theta is a positive angle. Now, how gonna define negative r and theta? We're gonna rotate this line segment 180. Okay, that's we're gonna define negative r and theta. You're gonna sketch this line, rotate it 180. That's that point gonna be negative r and theta. That's how to define negative r and theta. How gonna do it? First, you're gonna plot r and theta. Theta is positive. Then rotate this point 180. This gonna be negative r and theta. Then how gonna define r? Distance r is positive, angle is negative. Same thing. polar axis, that's the x-axis, polar axis. Here is origin. You sketch the angle, positive angle first, right? That's the line. Angle is positive. Then we gonna draw the angle negative and counterclockwise. That's gonna be negative theta. We find the distance from origin gonna be r. That distance gonna be r, that point. We find that point, that's gonna be r and negative theta. So the other side here, yellow, this distance from the origin 0 and this point, distance gonna be r, angle gonna be positive, that gonna be r and theta. That's how to sketch. R, radius r is positive, angle is negative. Angle is negative, you have to clockwise from positive axis. We learn how to plot the points with the polar coordinate. Now, let's plot the points when you have polar coordinate. Here is A, radius is 1, angle gonna be 3 pi over 4. Start point here, that's the polar axis. You're gonna sketch angle first, 3 pi over 4. Which quadrant, guys? That's the second quadrant. You're gonna sketch it. That's gonna be angle 3 pi over 4. That's to draw the line. Distance from origin gonna be 1. Then you plot the point A. Radius is 1. Angle gonna be 3 pi over 4. So keep in mind this order. Angle first, then find the distance from the origin on the line. Then you plot the point. How about this one? This one is 3 pi. 2 pi is 1 cycle is 2 pi, so you have to 1 cycle, then you go to pi more. That's gonna be, you find the angle first, that's gonna be 3 pi, but distance from the origin gonna be 2. So here is a 1, 2, here is a plot the point, that's gonna be B. Does it make sense? Next one, sketch the angle first, 3 pi over 4, we already did here. That's quadrant 2. Let's sketch 3 pi over 4. Draw the line. Here is radius gonna be negative. First you find the positive 3. Distance from the origin 3. 1, 2, 3. That's gonna be 3 pi over 4. Radius negative meaning is rotation, this one. The fourth quadrant. So that's gonna be rotation 180. Now you find the point right there. That's the C. C gonna be negative 3 pi over 4. Here is 3 pi over 4. Let's sketch another 3 more points. Here is, this time, angle is negative. Angle is negative. How gonna sketch angle is negative? You go to clockwise. So sketch the angle first. 2 pi over 3. That's gonna be start here, guys. All the way third quadrant. Angle is negative. That's the clockwise. Draw the line, but distance from the origin is 2. Then you plot the point D value right there, guys. Okay? That's how to find this point. How about this one? Pi over 2. Here is polar axis. Go to the pi over 2. That's 90. That's the y-axis, right? Then this line, distance from the origin gonna be 1. This distance gonna be 1. You plot the point right there. So this one is pi over 6, quadrant 1. Guys, pi over 6, we sketch the angle first. But distance from the origin is 3. This distance gonna be 3. So you plot the point F. So you have to keep in mind the angle is positive counterclockwise, angle is negative clockwise. Distance, you say R value negative, you find the first R is positive, rotating 180. So you guys just find the angle first, then you next is find the distance from the origin and plot the point. Another important thing for the polar coordinate is there is not only one representation for the point. So as you notice, 1, 5 pi over 4. Let's sketch this one. Angle is positive, radius is positive. So we're gonna sketch angle 5 pi over 4, gonna be third quadrant. So I sketch the angle first. Distance from origin is 1. That's the point in the third quadrant. But look at this representation. So how gonna sketch it? You're gonna find the angle first, pi over 4. That's the first quadrant. Then distance from the origin is 1. That's the point, 1 and pi over 4. But here is radius gonna be negative 1. So you're gonna rotate this point to the quadrant 3. So we're gonna rotate this one 180. So you find negative 1 pi over 4. Exactly same point they represent. Next one is 13 pi over 4. Guys, 13 pi over 4 is gonna be what? Guys, this one is 2 pi plus 5 pi over 4. Then there is one cycle and go more 5 pi over 4. Here is they're gonna be one revolution, then go to the 5 pi over 4. That's the third quadrant. Distance gonna be 1. You exactly plot the same point from previous two. Last one is that represent negative angle. That's this time clockwise, 3 pi over 4. So you going to here, third quadrant. Then distance from the origin is 1. That also represent the same point. So if we don't restrict the interval of R, interval of angle, polar coordinate have different representation for the point. That's keep in mind, everyone. Let's study how to convert from polar coordinate, rectangular coordinate, polar coordinate. First, we're gonna do rectangular coordinate. So, rectangular coordinate x and y, point P gonna be x and y. X represent distance from the y-axis, that's gonna be x. From here to point, from distance from x-axis to the point, that's gonna be y value. So that's gonna be changed to the polar coordinate. When you convert from the rectangular coordinate to the polar coordinate, I'm gonna say R is positive, theta is 0 and 2 pi. Otherwise, you have so many different representation. So what you have to do, we change from x and y rectangular coordinate, R and theta. How define the R? R is the distance between 0 and P. That's gonna be R value. Theta gonna be angle from positive axis to the line segment 0 and P. That's gonna be theta. So how gonna find the R, guys? That's the distance, right? R is gonna be square root x squared plus y squared. That's Pythagorean theorem. Theta, that's the trigonometry identity. We're gonna use tangent. Tangent theta gonna be y over x. Opposite of adjacent, y over x. How gonna find the angle? Gonna be arctangent to y over x. That's you're gonna find. That's how to convert from the rectangular coordinate and polar coordinate. When you have rectangular coordinate, you can convert to the polar coordinate r and theta. Now, when you have polar coordinate, that's gonna be r and theta this time. We have to find x and y. What do you know here? You know the r, distance between 0 and p. That's the r. Theta gonna be angle between positive axis to the line segment, right? So how gonna find rectangular coordinate? That's gonna be x and y. So look at this one. It is similar to the left side. We're gonna draw the right triangle from the pre-calculus. Then we're gonna find the x value. We're gonna find y value based on the right triangle. So how can find the x? Think about trigonometry value. What gonna be trigonometry for right triangle? So this one is adjacent. So we have to use cosine. Cosine theta gonna be x over r. That meaning is x gonna be r cosine theta. Y value gonna be, we can use trigonometry for sine. So sine theta gonna be y over r. Y gonna be r sine theta. So when you have polar coordinate r and theta, we can find x equal r cosine theta, y equal r sine theta. Let's just summarize coordinate conversion here, right there, guys. That's coordinate plane. This is coordinate plane. P is represent rectangular coordinate. The other P gonna be r and theta. That's the polar coordinate. R is distance from 0 and P. Theta gonna be angle. X gonna be x coordinate. Y gonna be y coordinate. So here is we say polar coordinate, r and theta. R gonna be have restriction positive or 0. Theta is one cycle. Right side is rectangular coordinate, x and y. So how gonna convert? R gonna be square root x squared plus y squared by using Pythagorean theorem. Theta gonna be we using tangent value y over x. Here is a rectangular coordinate from the polar coordinate. X equal r cosine theta, y gonna be r sine theta. By using this formula, you can convert from polar coordinate to the rectangular coordinate to the polar coordinate. Here is the first example to convert from polar coordinate to the rectangular coordinate. So first example is 1 pi. Here is polar coordinate. 1 is represent radius, theta gonna be pi. So I'm gonna plot the point 1 and pi. Angle is pi, r is 1. That's I plotted right here. Let's convert this polar coordinate to the rectangular coordinate. The meaning is x equal cosine theta, y equals sine theta. R is 1, theta is pi. X equal 1 cosine pi, y equal 1 sine pi. So cosine pi is negative 1, so x equal 1 times negative 1. Sine pi is 0, y equal 1 times 0 is 0. That meaning is negative 1 and 0. So here, let's thinking about rectangular coordinate. x value is negative 1, y value is 0. X going to negative 1 to the left, negative 1, y value is 0. Exactly represent that point. Let's do the second example, 2m pi over 3. Positive angle, distance from origin to the point is 2. R is 2, theta is pi over 4. So you're going to find the angle pi over 4, distance going to be 2 right there. Then you're going to plot the point. So that's the point, 2m pi over 3. So we want to find the x value, 2 times cosine pi over 3. Y value gonna be 2 times sine pi over 3. Cosine pi over 3 gonna be 1.5. That's gonna be 2 times 1.5. That's gonna be 1. Sine pi over 3 gonna be square root 3 over 2. 2 times square root 3 over 2. That's gonna be square root 3. So you find rectangular coordinate 1 comma square root 3. Here origin go to the right 1. Right? Go up. Y value is square root 3. That you find rectangular coordinate 1 comma square root 3. Here is example 4, rectangular coordinate to the polar conversion. So we have rectangular coordinate 1, negative 1, which meaning is x equal 1, y equal negative 1. So x equal 1, y equal negative 1 is this point. So how gonna find r and theta? R is represent this distance, theta is angle, right? R is square root x squared plus y squared. Theta is, let's say, tangent theta y over x. So let's find R first. R gonna be 1 square, x equal 1, y equal negative 1. 1 square plus negative 1 square. Here is a square root 2. That's gonna be here, distance from the origin to this point. The length of this line segment is square root 2. We need to find the angle. When you find the angle, you have very careful. Tangent theta, guys. Tangent theta, y is negative 1, x equal 1. Tangent theta is negative 1. Theta is fourth quadrant, not the second quadrant. So angle, tangent value is negative, quadrant 2, quadrant 4, but our point in the quadrant 4, theta gonna be, what is it, guys? Theta gonna be 7 pi over 4, not 3 pi over 4. If you pick the 3 pi over 4, that's second quadrant. So when you pick the angle, you sketch the point, make sure where point lies. So find the right angle. So you have polar coordinate gonna be square root 2 comma 7 pi over 4. You have different representation for the point, but I have a restriction. R is positive, theta is 0 and 2 pi. Let's have another example right here, 0 and 2. Where is 0 and 2? Let's plot. Here is 0 and 2, right? X equals 0, y equals 2. You're right there. So we want to find R, that distance gonna be, find it. Let's find distance first, guys. Distance R gonna be square root 0 square plus 2 square. That's gonna be square root 4. Distance gonna be 2. What is theta? Theta gonna be what, guys? Theta gonna be angle from positive axis from here. You don't have to calculate, right? Theta is pi over 2. So you have polar coordinate 2 comma pi over 2. So I want you plot the point to find polar coordinate, rectangular coordinate, make sure where point lies. we learn how to represent a point from polar coordinate to the rectangular coordinate, polar coordinate. Now, in this slide, we're gonna convert from rectangular equation to the polar equation. Guys, we already did with the parametric equation, right? So here is rectangular equation because they have y and x. Then we're gonna change it to the polar equation, meaning is r and theta. So what is y value? What is x value, guys? Remember when you convert from rectangular coordinate to the polar coordinate? So let's get the idea. X gonna be r cosine theta, y gonna be r sine theta. So you're gonna plug in y equal r sine theta, x equal r cosine theta. When you see it, guys, this one is gonna be divided by r cosine theta, both sides. Then left side r sine theta over r cosine theta is 1. R is cancelled out. Sine over cosine theta gonna be tangent theta. We have tangent theta gonna be 1. Tangent theta gonna be 1. Theta gonna be pi over 4. That's we find polar equation. Let's have another example. X squared plus y squared 1. X gonna be r cosine theta. Y gonna be r sine theta. You plug in here. R cosine theta square plus r sine square theta equal 1, which meaning is r square cosine square theta plus r square sine square theta is 1. R square is common factor. Cosine square theta plus sine square is 1, meaning is r square is 1. R might be positive, negative 1. That's how to find equation, polar equation from rectangular equation. Now, how gonna convert from polar equation to the rectangular equation? This is a little challenging. So first, r equal to, we have conversion formula right here, x r square equal x square plus y square. So you might thinking about r equals square root x square plus y square, but this one is much easier to use it. That's not square root to it. So tangent theta is y over x. How can find r square? So you're gonna do square both sides. R square gonna be 4. When you square both sides, r square replaced by x square plus y square. That gonna be x square plus y square equal 4. That is represent a circle. Center is 0 and 0. Radius is 2. How about theta is pi over 4? This is a polar equation. We want to change rectangular equation. So we're going to using second this one, tangent theta. So tangent theta going to be y over x, but theta going to be pi over 3. So tangent pi over 3 equal y over x. Tangent pi over 3 is square root to 3 equal y over x. You times x both sides. Y equals square root 3x. That's represent the line. Slope gonna be square root 3. So let's have another one. R equals 4 cosecant theta. It's very challenging, guys. So only here we gonna using this time is we have changed cosecant theta. We only have sine and cosine. So we have changed this one by using trigonometric identity. So 1 of sine theta. So R equals 4 sine theta. So we want to simplify this equation first. You times both sides sine theta. So R sine theta is 4. What is R sine theta? R sine theta gonna be x. R cosine theta gonna be X, R sine theta gonna be Y. So this one, R sine theta replaced by Y, that gonna be Y equal 4. Guys, make sense? This is Y equal 4. One more example. R is 2 cosine theta. This is very tricky. R is 2 cosine theta. We have R cosine theta is right here. But left side is R, right side is just cosine theta. But we need R cosine theta. So what you have to do, you times R both sides. So R square equal R cosine theta. Then you're going to replace R cosine theta is X. R square is X square plus Y square. So we're going to say X square plus Y square is 2X. So you move the 2X. X square plus Y square minus 2X. This is represent circle. Okay, guys, you understand that? This change from polar equation to the rectangular equation, you're going to using this 4 conversion formula to change the equation. Now we're going to sketch polar coordinate R equal f of theta. Let's start very simple one, R equals 0. R equals 0 meaning is distance from origin is 0. That represent point on the origin. That's the R equals 0. What if, guys, R equal 1? That's gonna be represent what? We have previous example, R square equal 1. That's meaning is X square plus Y square is 1. That's gonna be circle, center is 0 and 0, radius is 1. Another way to understand this one is distance from origin is 1. You correct all the point, distance from the origin is 1. That's represent the circle, R equal 1. Radius gonna be 1. So next one is R equal 2. Radius, distance from the origin is 2. That's represent circle with radius is 2 right here, guys. That's represent circle. Radius gonna be 2. One more. R is 3. That curve represent the circle. Center is 0 and 0. Radius gonna be 3. That's the polar curve with R equals something. Let's sketch the basic polar curve. This time theta is pi over 3. So theta is pi over 3. Guys, remember previous slide, theta is pi over 3. When you convert rectangular equation, that's represent the line. So how gonna sketch this one? Let's just sketch the angle first, guys. This is theta is 0, this line. Theta is pi over 3, that's the angle. You draw the line. R is positive, because R is positive meaning is distance from the origin or the positive here. Any R value. So you draw the line. R is positive. R is negative meaning is you rotated this line to the third quadrant, meaning is R is negative. So we have theta is pi over 4 is a straight line, go past through the origin. That's the theta is pi over 3 in the polar curve. So another example is theta is negative pi over 4. That's the negative angle clockwise. You're going to sketch the theta is negative pi over 4 with R is positive with the fourth quadrant, draw the line, any point under this line. But we consider R is negative, rotate this line 180, the other side, that's R is negative. This line represents theta is negative pi over 4. Now let's sketch R is 2 cosine theta. So how gonna sketch this one, guys? First, we're gonna make a table, guys. We put the theta is right there. R is depends on the angle. Theta we're gonna put the angle. Theta is 0, pi over 6, pi over 4, 3 pi over 3, pi over 2. When you plug in theta is 0, R gonna be 2 cosine 0 is 2, R is 2. How gonna sketch it? Theta is 0 is x-axis. Distance from origin is 2. You plot the point 2 there. That's the 0 and 2 you plot it. So theta is pi over 6. R is 2 cosine pi over 6. Cosine pi over 6 is square root 3 over 2. 2 times square root 3 over 2. 2 is cancel out. Square root 3. Pi over 6 square root 3. Here is pi over 6 line. Distance from origin is square root 3. You find here, you plot it. Square root 3 over pi over 6. Okay, you plot the point. Next one is theta is pi over 4. R is 2 cosine pi over 4. Cosine pi over 4 is square root 2 over 2. Then R is square root 2. So theta is pi over 4. R is square root 2. Angle is here. That's the pi over 4 line. You find the distance from origin, square root 2. Find the distance from origin, square root 2. You plot it. Square root 2, pi over 4. Now, theta is pi over 3. R is 2 cosine pi over 3. Cosine pi over 3 is 1.5. That's gonna be 2 times 1.5 is 1. That's gonna be 1. So pi over 3 line right there. Distance from origin is gonna be 1. That's the circle we talk about. That's gonna be, plot the point is right there. That's the 1. Right? Pi over 2. R is 2 cosine pi over 2. Cosine pi over 2, 0. R is 0. Right? So pi over 2 is 0. Pi over 2 is here, this line. R is 0 is origin. If that's plotted. You connect to the point, guys. Okay? That's connected. So the other side, we sketch the theta is first quadrant. Theta is second quadrant. But that's we're going to sketch next slide. We sketch the first quadrant angle between the 0 and pi over 2 here, guys. So we sketch it. Angle is first quadrant, 0 and pi over 2. Now, angle is second quadrant, 2 pi over 3, 3 pi over 4, 5 pi over 6 pi. Let's say theta is 2 pi over 3. Theta is 2 pi over 3. What is R gonna be? Negative 1.5. That's the cosine 2 pi over 3 times the 2. That's the negative 1. So very careful here, guys. Angle is 2 pi over 3. That's the second quadrant. R is negative. So R is negative meaning is you rotate that point 180. So 2 pi over 3 is right here, this line. R is 1 is here, but you have rotate 180. That's quadrant 4. That's you're going to sketch it. 180 rotated. That's negative 1. 2 pi over 3. That's going to be cos quadrant. So our next one is theta is 3 pi over 4. R is cosine, 2 times cosine 3 pi over 4. This is negative square root 2 over 2. 2 times negative square root 2 over 2 is negative square root of 2. So same thing here. R is negative 2. You have second quadrant. This line is 3 pi over 4. Then you have negative square root. So positive first, square root 3 pi over 4. Negative meaning is 180 rotation. That's gonna be fourth quadrant. You sketch it. Theta is 5 pi over 6. That's gonna be, guys, right here. R is 2 cosine 5 pi over 6. That's 2 times minus square root 3 over 2, that's going to be square root 3. That is 5 pi over 6 negative square root 3. Same thing. Second quadrant angle gonna be going to the fourth quadrant point. Okay? Theta is pi gonna be cosine. 2 cosine pi gonna be 0. Oh, no. 2 cosine pi gonna be negative 1. That's gonna be negative 2. So negative 2 right here. Pi gonna be negative x-axis 2 pi rotating 180. That's going to first quadrant point. That's gonna be right here, negative 2m pi. So when you connect to this dot, you have another semicircle. Now we have first quadrant angle, second quadrant angle, second quadrant, the point gonna be fourth quadrant. So we're thinking about angle is third quadrant, that's gonna be cosine value negative. So that's, you sketch the first quadrant. Fourth quadrant cosine is positive. You're gonna have the same point. So this one is 1, 0 and pi over 2. Here is a half semicircle, pi over 2 to the pi. Pi to 3 pi over 2 here. 3 pi over 2 to the 2 pi gonna be here. We sketch the curve for r is 2 cosine right here. That's the circle. Let's sketch the curve r equal 1 plus sine theta. So guys, remember where sine value is positive, where second sine value is negative. Quadrant 1, quadrant 2, sine is positive. Quadrant 3, quadrant 4, sine is negative. Let's thinking about first quadrant. Theta gonna be 0, pi over 6, pi over 4, pi over 3, pi over 2. So let's find r value. R is theta is 0, 1 plus sine 0. Sine 0 is 0, that's the 1. So angle is 0, r is 1, that's the plot first one. 0 and 1 and 0. Theta is pi over 4, r is 1 plus sine pi over 4, that's gonna be 1.5, that's gonna be 1 plus 1.5, 1.5. Theta is pi over 6, 1.5, theta is pi over 6 right here, 1.5 around here, guys. So let's plot it. Theta is pi over 4, r is 1 plus sine pi over 4, that's square root 2 over 2. 1 plus square root 2 over 2 is 1.7. R is pi over 4 is right here. You're gonna plot it, 1.70. Theta is pi over 3. R is 1 plus sine pi over 3, which meaning is 1 plus square root 3 over 2. That's the 1.87. Theta is pi over 3. Distance from the origin 1.7. That's almost 2 value plot right there. Then theta is pi over 2 gonna be r is 1 plus sine pi over 2. Sine pi over 2 is 1. That's 1 plus 1 is 2. Theta is pi over 2 is right here. That's gonna be 2. So you're gonna plot it. You're gonna connect it, right? So second quadrant. So now you're gonna find this angle is second quadrant, but sine value is right here, guys. Sine 2 pi over 3, sine pi over 3, exactly same, 1.87. Sine 2 pi over 3, exactly same. R value is the same, 1.87. Symmetry over y-axis, you plot here. Sine pi over 3, sine 3 pi over 4, exactly same value. That's going to be 1.70. Here is a pi over 3, exactly same R value, you plot here. Sine 5 pi over 6, sine pi over 6, exactly same value, R is 1.5. That's you're going to apply here. So now sine pi, let's go to the pi. Sine pi gonna be what? 0, right? So R is 1. Sine pi gonna be, angle pi gonna be right here. R value is 1. You're gonna plot 1. So you're gonna connect it. That's the second quadrant angle. Let's have a third quadrant angle. That's the 7 pi over 6. R is 7 pi over 6. This value is negative 1 minus 1.5, 0.5. That's going to be third quadrant, guys. That's third quadrant right here. You're going to plot it. 0.5, you plot it. That's the 7 pi over 6. Guys are using this one. Here is a 7 pi over 6. This line distant from the origin, 0.5. Let's go into 5 pi over 4. Same thing. R is 1 plus sine 5 pi over 4. This value is negative 1 minus square root 2 over 2. That's 0.30. This is line. 5 pi over 4. Right? 0.3. That's 0.3. Let's go to 4 pi over 3. That's the R plus sine 4 pi over 3. That's going to be 1 minus square root 3 over 2. 0.13, getting close to the origin. That's you plot it. Then you connect to these points. Before that, 3 pi over 2 sine 3 pi over 2 gonna be negative 1. R value gonna be 0. That's going to the origin. So you connected to this point. Fourth quadrant angle is exactly same value. Let's sketch the fourth quadrant. 4 pi over 3. Same thing is 5 pi over 3. That's plotted. 5 pi over 4. That's the same thing. 7 pi over 4. You plot it here. 7 pi over 6. That's 11 pi over 6. Same value, 0.5. 2 pi gonna be, that's the same thing. Sine 2 pi sine 0 is the same. That's R is 1. That's gonna be 1 here. So then you connect to this point. You sketch the R equal 1 plus sine. Let's sketch polar curve R equal cosine 2 theta. This time I'm gonna use R equal cosine 2 theta graph. So here is a theta, here is R. We sketch cosine 2 theta. This graph is period gonna be pi because here is a 2 cosine graph has period 2 pi. So 2 pi divided by 2 gonna be pi. So R equal cosine 2 theta period is pi. So let's sketch the polar curve 0 and pi over 4. 0 and pi over 4. That's we're going to sketch it. 0 and pi over 4. R value start 1, then going to 0. That's how I sketch the polar coordinate. Theta is 0 and pi over 4. That's moving it, guys. Moving it. 0 and pi over 4. Curve gonna be start R equal 1 to the 0. That's the first part. 1. Okay? Now, go to the second part. Pi over 4, pi over 2. That's the R value is negative. So, pi over 4, pi over 2, R value is negative, meaning is you cannot sketch here. 180 notate, you're going to sketch third quadrant. So, R theta is pi over 4, move to the pi over 2. Your graph going to be third quadrant. Start 0, here is a start 0, going to the negative 1, that's why here. Let's go to third one. Pi over 2, 3 pi over 4, that's gonna be R value increasing, but pi over 2 is negative 1, 3 pi over 4 is 0. So now, pi over 2, 3 pi over 4. You're gonna move, angle gonna be pi over 2 to the 3 pi over 4. Graph R value still is negative. That's why you sketch the fourth quadrant right here, guys. So negative 1 to 0. Now, fourth one, 3 pi over 4 to the pi. That's the positive. Here is 3 pi over 4, the theta positive. You sketch the graph is right there. 3 pi over 4 is 0, pi gonna be 1. So 0 is right here, 1 is right there. That's you're gonna first move the theta 3 pi over 4 to the pi, graph gonna be 0 to pi. Everyone understand how can sketch the graph? Next one is pi to the 3 pi over 4. That's starting point to 1, decreasing to the 0, still positive. So you're going to sketch theta is pi to the theta is 5 pi over 4, positive. You're going to sketch right here, start point 1 going to 0. So theta is pi to the 5 pi over 4, you sketched here. Same thing is another one, 5 pi over 4, 3 pi over 2 negative. Here is a 5 pi over 4, 3 pi over negative, so you cannot sketch the graph here. 180 rotated, you sketch there. They start point 0, end point -1, so you have to sketch right there. You're going to sketch right there because 5 pi over 4, 3 pi over 2 right here, but r is negative, then 180 rotation right there. 3 pi over 2, 7 pi over 4, 3 pi over 2, 7 pi over 4. Here is negative, so you cannot sketch here. You're going to sketch 180 rotation, second quadrant. That's you're going to sketch there. Last part, 7 pi over 4, 2 pi, that's positive. You're going to sketch 7 pi over 4, 2 pi, you sketch this part. So we call this is a four-leaved rows. The polar coordinate sketched a lot of curve we cannot sketch with rectangular equation. What do you learn this session, guys? First, polar coordinates offer a different way locate the point by using distance from origin and angle from the positive x-axis. Second is many curves are easy to understand, sketched in polar form. Third one is you learn how to convert between polar and rectangular form, help reveal connection between the two systems, make complex curve easy to analyze.